This is a demo video for our project in DSCI 501, and we have implemented an emulated Firebase and a forum based on Flask that can demo the real-time synchronization functionality in the emulated Firebase. Let me first introduce the functionalities for our emulated Firebase. We have implemented a user register and login endpoints. Like I can register a user with this name and password, and it returns the username already exists because I have already registered, and I can get my authentication token by using the .login endpoint. As you can see, this is the token. And then let me demo the CRUD API, including post, put, and patch. This is a post command that can create a collection, because without a valid collection, we cannot do any operations. So in this command, we want to create a collection. Whose name is DSCI 501. It says that the collection created successfully. And then next, let's put something into this collection. In this command, I want to put a document whose key is XYXJ and whose value is the following input data. And it is created successfully. And let's verify this by using the get command. As you can see, the information get from the get command is exactly what we just put in the put command. Next, let's demo the post command. So in this command, we want to post an info JSON object under the key LCC. And it says the resource is created successfully, and it returns the unique ID for the post to us. And let's copy this. Next, let's verify the post command with the get command. As we can see, this is just the expected result. Next, let's have a look at the patch command. In the patch command, we want to modify the info dictionary we just put in under the key YXJ to add a city Los Angeles value pair, key value pair. Okay, correct. And let's use the get function to verify this. Yeah, correct. Then let's use the delete command to delete what we just put and post. And all the deletion is successful. And let me invite my teammates Xiang Jieyuan to demo more functionalities of our curl command interface.
Now I will introduce how to use the get function and the filter function. First, we need to add some data into our database. We need to add the first data and shows added successfully. And we successfully added the second one. The third one. Now we have added all the data into our database. And now we'll test the database. Yeah, you can see we have successfully added all the file data in our database. And now I will show you how to show some information about William. Now you can we get the Williams info. And if we want to order by the Williams infos under this info, we want to order by key. Now you can see there are two keys. The first one is address, and the second one is country. And if we want to order by the key, we can use the next command. Yeah, we want to order by the key. And now we can see we get the address first and the country second. And we can also get William's each homework score. Now you can see we get his all the homework score. And if we want order by its value now, and it will return error. You can see because the value has not made index, so we should create index first. You can see we will create index under DSA 551 under specs and the course name DSA 551 and the homework, and we want to add an index order by index called value. Now you can see we have successfully created the index, and now we can order by the value. And because this is a dict in Python and it has no order, so we can use the limit first to check the first value should be 17. And limited to first equal 1. And yeah, you can see we get the homework 2 and its value is 17, and this is the minimum value. And now we can show other order by, for example, you can see our data structure. There are 5 data, and for example, Bob, and he has some and he has info and the subject data, and under the info he has address and country, and under country. And under country it has continent and country field. And if we want to order by all the data, all the 5 data under order by this country field, we can. I will show this next. This command we will get all the data, and the order by value is info, country, and country. And it's of course return error because we have not created index for this field. So we will create index next. We will create index under the DSA 551 collection and under info, and the index field is info, country, country. We have created index successfully. And now we can order the value. Yeah, it is hard to say, so we can use limit first to check that our answer is right. We know that Williams, we can see Williams' country is China, John's country is USA, Elsie's country is Brazil, Jerry's country is Egypt, and Bob's country is France. And if the data is correctly ordered, when we choose the first, we will get Elsie, right? Yeah, we get the LC data. It shows that our have successfully ordered the data. And we can see the lost data. The lost data should be Jason because his country is USA, and it is the lost. Yeah, we got the Jason data. Yeah, that's a detailed demo of the get and filter function. That's my teammates Chen Zhaolin to show our web app.
For our web app, we have developed a forum that user can sign up their account and sign here. And we have signed up before. So let's check the user information. So but as you can see, the user successfully signed here. And let's publish some questions like test, and it will appear here successfully. And we also implement a search functionality where we can search our questions. Yeah. To further demo this, let's add more questions like hold one, and let's search test, and let's search hold one. This is the basic functionality for the web app, and we also need to demo the real-time synchronization functionality. Here we will use a patch command to modify the content for the users post. And this is equivalent to modify the underlying MongoDB documents. As you can see, the content is homework 1 here, and let's modify this homework 1 to be homework 10. And without refresh, as you can see here, the content has become homework 10. And basically, that's everything we have implemented in our final project, and that's it. For the implementation of the emulated Firebase, let's first look at the data structure that's stored in the MongoDB backend. The biggest challenge we met in this project was the fundamental differences between Firebase real-time database and MongoDB, where the former is a tree-based database, while the latter is a document-based database. To emulate Firebase using MongoDB is really tricky. In our implementation, we use a structure where each document in a MongoDB collection is like this. There is a unique key in each document, and its value is any JSON object. By using this structure, we can write CRUD APIs more intuitively. Next, let's look at the Flask structure. In our project, we use Flask framework to handle URL routing and other functions like authentication, socket. With the Flask framework, we can separate our development to make it more manageable. Most of the codes are inside this app directory, where each file inside this directory handles a method or a module. For example, this put.py tackles the put method, post.py tackles post method, and create collection, create index, create listener methods. And this auth.py handles all the authentication related methods. Each file registers a blueprint in this initial.py, as you can see here. Within each file, we only need to write functions with decorators provided by Flask, so that we can develop more separately. For more details, you can refer to the code in Google Drive. Next, let's look at the CRUD API. After setting up the Flask framework, we start our development on the CRUD RESTful APIs, which consists of put, post, patch, get, and delete. For all of the APIs, it's necessary to check and parse URL paths and input data, which are solved by the following functions here. They are input data check, input data transform, and check path. For the input data check, it checks if the input data is valid, ensuring no keys contain dots, as MongoDB does not support this correctly. For input data transform, it transforms the input data if it is a list. For check path, it checks if the path is valid, removing empty fields and ensuring there are no fields containing dots. Then let's look at the put, post, and patch methods. For put and post, we can see that post can be implemented by using put by modifying the input data to include a unique ID. So let's look at put first. Basically, the put function is implemented by the process put function here. The process put function is divided into 3 parts based on the length of the path. If the length of path is 1, we just delete all the documents in the collection and replace with the input data. Because in this case, we are overwriting on the root path. If the length of the path is more than 1, it attempts to update the documents with the MongoDB update 1 function. If successful, it returns a 0 or 1 code and related messages. If this is not supported somehow, because MongoDB cannot translate all the features of Firebase, we will manually create a data using the update doc function here, and then replace it with the path that user specified, and then return the related corresponding messages. Then let's look at the post.py. As we have mentioned before, post can be implemented easily with put. This is the post function. Basically, we are creating a unique ID, post ID with the uid.uid4 function, and then modify the path to include this post ID, and then use the process put function to insert this data with this unique ID. If the status code is not 400, which means there is a failure, we will update the return message to include our unique ID under the name field here. As for patch, the process patch function is responsible for updating or adding new data. It basically utilizes the MongoDB.update1 function and return the corresponding messages. Actually, the patch is quite straightforward and well supported by MongoDB. In addition to the CRUD RESTful APIs, we have also implemented functions like registration, grade collection, index, and listeners to support more features. Let's go through each of them. As for user registration and login, it requires, it's inside the auth.py file. As for user registration and login, it requires an authentication system that is built on the Flask framework. For register, the endpoint receives a post request that containing the user's desired username and password. If the provided information is valid and the username does not already exist, the password is hashed using the generated password hash function. And the new user is added to the admin database here. A new user specific database is also created here. And we also create a collection index under the user's database, because the user needs to for the login endpoint, you receive a post request, and just like the register endpoint, it receives user's name and password, and it will verify using the check password hash function and return the corresponding messages. The most important part here is that it will return an access token to user, and user must include this access token with an additional header in their curl command. As for creating collections, index, and listeners, they are under the post.py file. For the create collection endpoint, it will create collection under the user's database and add a new entry in the index collection, because the user might want to create the corresponding index for that collection. For the create index endpoints, it receives a path like this. Basically, it tries to create an index in MongoDB. However, as we have mentioned, MongoDB is not that capable of supporting all the features in Firebase. So if the collection, if the index is not created, it will still document it in the index table under the user's database, and the index will be created anyway. For the create listener function, as you can see here, it defines a function that calls chain string listener, which is responsible for create a chain string listener on MongoDB on the background. And as long as there is a change on the specified collection, this thread will emit messages so that the client can use a socket to receive the messages and do whatever they want.
Now I will explain the detailed logics of the get function and the filter function. First, when a command need to get data from get function, we will need to check some items. For example, here we check the identity, we check the pairs, and after all the checks, we will use this 6 flag to report the status of filter function. For example, if the command use the order by field, we will set this order by flag is true, and we'll use the field documents function to get all the data and return the data to the command. For find documents function, first we need to get the DB cursor, and when we get the DB cursor, we will use the transfer documents. This function will use the DB cursor and the passage to get all the data we need. And after that, we will, if a command has order by field, field, we will check whether the field order by field has index, and if it has index, we will use this function filter document function to realize the order by function, and if it still has some limited to last filter or limited to first filter, we will use the logic here's code to return the corresponding numbers of data to the user. And if the command has order by field, but the order by field has not index, we will throw error and notify the user that he should create index first. And if the command do not has order by filter but has other filters such as limit to last filter or start as filter, we will also throw error and notify user that he should not be done. This filter should not be done without order by operation. And for filter document function, we divide it into three parts: order by store key, order by dollar value, and order by any fields. For how to order the data, here we use a Python sorted function and the lambda expression to achieve it. That is the basic logics of the get and the filter function.
Hi, my name is Xiao Lou. Today I'm going to talk about my code for the project. My first job is to create a delete API. So I divide that into 4 cases. The first, when we receive a URL, which tells us to delete all the tables because there's nothing after the local host. So we will drop all the tables in the database. And if the table is not found, we will return an error. This is the second case. In the third case, we found the table, so we want to delete it by the drop function. In the fourth case, we found the table and we want to delete the element. So at first, we need to check if the element exists or not. So if not, return error. If yes, we will find that element and delete it. That is a case when we have 2 elements in the URL. If there are more, which means we have many branches of elements. So let's go to the MongoDB and see our database has data pairs. They have pairs, and the key is always a number. So if the path here is a number, which means we want to delete its value. So let's go to the remove our to function. So if the key is what we want, and we will delete the value. And otherwise, it could either be the value or the key. So we will delete the whole pair. What did I do here? I tried to drop the I tried to copy everything here, and I will drop the I will drop everything here, but I will paste back everything except this one. So it's equivalent to the delete process. That's it for the delete function. My second job is to make a test file. So I try to make functions. Since our project is to emulate the Firebase system, we want to find if our output from the MongoDB is same as the output from the Firebase. So I made some functions. For example, for get, I try to return the output from MongoDB, which is res1, and res2 is the output from the Firebase. If the 2 outputs are equal, it will return true. I made the function for every RESTful API. So by doing this, I made some complicated test cases, such as those nested dictionaries and nested lists, so I can test if our program is robust enough. So our application is using the MongoDB API, and I want to replace it by our own MongoDB. So I made some functions. So at first we have a table called user. It contains all the user name and username, which is email, and their password. So if the password getter returns a password during the sign up process, that means that email has already been signed up. otherwise it's not. And then we also have add account for the sign up process. We will add the email and the password typed by user to the user table. And then we have add email. Why do we have this? Because when we are signing up, when we are creating a new account, we need to send a code from our computer to the user's email, and we will add the real code and its email to our database. And we will also retrieve the code and its email pair from our database to see if it's matched to the code typed by the user. If yes, we will say the sign up is successful. And then we will delete the email from the email table. Then the question saver function. This is a little complex because we are doing two things. The first, we are adding those things: author, title, content, create a name, create a time, to the author table. This table helps us to show all the posters on the front page, and that front page will be ordered by the create time. And then I will add them to another table, which is publish. This table contains 5 items. It is like first the 4 items plus the ID. What is ID? ID is the one we are using post function to add those 4 items to the order table, and then we get the ID from the post. And then this ID will be added to the publish function. And the publish function is their keys are the title. So you can search for one poster by its title. Get question. What does this function do? It helps us to search from the publish table because all the keys are title. So you can just simply search by the title. And the get question from order. This one is what I said. All the elements from the order table, they are sorted by the create time. So we found it's interesting that we found the order by function of curl is not working here. So we use the sort function by Python, and then it helps all the posters on the front page to be sorted. And that is everything I did, all the code I typed for this project. Thank you.
For the forum real-time synchronization, we need to use the .create listener here to create a listener on the collection order, so that any changes on order can be made to the socket client defined here. Besides this, we need to initialize the socket client that can capture the emitted messages from our emulated Firebase, as well as a socket server that emits the capture messages to all the clients that receives the HTML. In addition to set up the Flask side mentioned here, as we can see, we import socket.io and Flask socket.io. This is the socket client, and this is the socket server. Besides this, we need to add some code in our HTML template, like this. And user can define their own functions. And here, in this form app, we receives and changes from the Flask app 1 and update the related content in the user's post. The key point here is that you need to include a script here and another script inside the base.html, which you can check out in our code.